NASA's James Webb Space Telescope has hardly opened its eyes, and already the universe feels new, more mysterious, and more beautiful than humanity's dreams. All these little dots it sees are stars. All these little dots are galaxies, some of which are bigger than our own. Breaking news suggests we may have found potential evidence of intelligent life beyond Earth. This could be a huge discovery. What's most exciting about this remarkable instrument we put in space is that it's finding things we didn't expect and can't yet explain. That forces us to revise our understanding of the universe. JWST is so powerful that, with enough time, it could likely detect any galaxy that has ever formed. It's truly that advanced. The question that persists, are we alone in the universe? A recent discovery may reshape how humanity sees itself in the cosmos. The James Webb Space Telescope, launched on December 25, 2021, has captured the clearest images yet of Proxima b, an exoplanet orbiting Proxima Centauri, the closest star to our Sun. These images show a world strikingly similar to Earth, stirring global interest and speculation. Proxima b, once dubbed Earth 2.0 by some scientists, appears to have conditions that might support life, but there's a twist. Evidence suggests the planet may already be inhabited. The following account explores the discovery of Proxima b, the findings from JWST, and the profound implications for humanity's future. Based on the latest developments as of May 2025, Proxima b, a rocky world within its star's habitable zone, was discovered in 2016. It lies just 4.4 light-years from Earth. Cosmically speaking, it's right next door. Orbiting the red dwarf Proxima Centauri, the planet is about 1.2 times the mass of Earth. Its position in the habitable zone, often called the Goldilocks zone, suggests temperatures could allow liquid water, a vital ingredient for life as we understand it. This makes Proxima b a compelling candidate for hosting life. From simple microbes to potentially complex civilizations, red dwarfs like Proxima Centauri are smaller and cooler than our Sun, but can live for trillions of years, allowing extended time for life to develop. Yet Proxima b faces major obstacles. Its host star is volatile, frequently emitting intense solar flares that could strip away the atmosphere and expose the surface to harmful radiation. The planet is also likely tidally locked, one side always facing its star in constant daylight, the other in endless night. The narrow zone between them, called the Terminator line, might have more moderate conditions suitable for liquid water and possibly life. The discovery of Proxima b has sparked imaginations across the globe. A rocky planet in the habitable zone of the star closest to us raises hope for a future home for humanity. If Proxima b has a thick enough atmosphere, it might protect the surface from stellar flares and maintain habitable conditions. The Terminator line, where temperatures are more balanced, could offer a refuge-an environment of eternal twilight. These possibilities make Proxima b a focal point of exoplanet research and a beacon for interstellar exploration. The James Webb Space Telescope has revolutionized our view of the universe. With a 6.5-meter primary mirror and infrared technology, JWST can see through cosmic dust and detect heat signatures invisible to previous telescopes. Positioned in a halo orbit at the Sun's L2 point, it offers unparalleled clarity when observing distant worlds like Proxima b. Instruments like the near-infrared camera NIRCam and mid-infrared instrument MIRI allow scientists to examine exoplanet atmospheres for signs of water vapor, carbon dioxide, methane, and other potential biosignatures. A shocking revelation emerged when JWST turned its focus on Proxima b. Scientists expected to study its atmosphere and surface conditions. Instead, they detected a faint, steady glow on the planet's dark side. This light didn't resemble natural phenomena like volcanoes or auroras. It was uniform and widespread, akin to artificial lighting, like seeing a city from space. Reported in early 2025, this glow suggests the possibility of an advanced civilization generating artificial light on a planetary scale. The glow covers large areas of the planet's surface, hinting at sprawling urban zones or connected cities. If confirmed, This could be the first concrete evidence of intelligent extraterrestrial life or discovery that would mark a turning point in human history. How could a civilization exist on such a challenging world? Scientists have offered several theories. One is that life may have developed along the Terminator line, where conditions are most stable. This narrow band of perpetual twilight could support agriculture, water systems, and sustainable communities. Another theory posits subterranean cities. Life could thrive below the surface, protected from radiation and extreme temperatures. These underground habitats could use geothermal energy or advanced climate systems to remain livable. Earth's own bunkers and polar research stations offer real-world analogues. A more advanced civilization might use terraforming technology. Massive domes or atmospheric shield could shield entire regions from radiation and temperature extremes. These ideas, while speculative, align with our own long-term goals for surviving on planets like Mars. The planet's extreme temperature differences could also be harnessed for energy. The hot side's solar energy and the cold side's geothermal heat might together power vast cities. The observed artificial light could reflect this kind of infrastructure. Biologically, life forms on PROXIMA may have evolved to withstand high radiation and wide temperature swings. Much like extremophiles on Earth thrive in deep-sea vents and hot springs, alien organisms might have adapted in equally extraordinary ways. The scale of the light observed implies advanced technology. If these beings can illuminate an entire hemisphere, they may also be capable of space travel, possibly exploring other planets in their system like PROXIMA C, discovered in 2020. That leads to a profound question. Are they aware of Earth? And if so, what are their intentions? The artificial light on PROXIMA B suggests two main possibilities: a flourishing civilization or remnants of a lost one. If it's the former, the light could come from cities and infrastructure, possibly including communication arrays. If it's the latter, the light might be produced by autonomous systems still running in the ruins of an extinct society. Either scenario challenges our views of life in the universe and urges caution as we consider our next steps. Not all scientists accept the artificial light explanation. Some suggest natural causes like glowing geological processes or atmospheric phenomena. While these ideas are less likely, they highlight the importance of more data. Upcoming JWST missions scheduled for late 2025 aim to gather spectroscopic information to confirm the light's origin and to search for biosignatures in the atmosphere. Yet even though PROXIMA B is close in cosmic terms, reaching it remains an enormous challenge. At 4.4 light years away, even our fastest spacecraft would take tens of thousands of years to get there. Chemical rockets would need over 80,000 years. Advanced ion propulsion, such as NASA's X-3 thruster, still wouldn't get us there in a human lifetime. One initiative offers a potential breakthrough. The Breakthrough Starshot project, announced in 2016, proposes sending tiny, lightweight probes using laser-powered sails at up to 20% the speed of light. These nanocrafts, weighing just grams, could reach PROXIMA B in 20 to 30 years and send back images and data. In 2024, the project successfully tested laser sail technology in low Earth orbit, marking a critical step forward. Looking ahead to the 2030s and 2040s, other efforts aim to follow. NASA and global partners are developing next-generation telescopes, like the Habitable Worlds Observatory (HWO), which will focus on studying exoplanet atmospheres. Radio astronomy projects like the Square Kilometer Array (SKA) may even detect alien transmissions from PROXIMA B. If intelligent beings do inhabit PROXIMA B, should we try to contact them? This question brings both logistical and ethical dilemmas. Radio signals would take over for years to reach the planet, and another for any reply. Earth has been broadcasting since the 20th century, from music and talk shows to deliberate messages like the Arecibo message of 1974, but we've yet to receive a response. Crafting a new message to PROXIMA B would require careful thought. Mathematical patterns like prime numbers might serve as a way to demonstrate intelligence. Yet the risks remain. A civilization more advanced than ours might see us as a threat or opportunity, much like historic encounters between human cultures. On the other hand, they might help us, sharing knowledge or technology. The absence of alien signals elsewhere, the Fermi paradox, adds another layer of complexity. Perhaps civilizations destroy themselves before they can reach out, or perhaps they choose silence. Many experts urge caution, recommending that humanity observe before making contact. If the inhabitants of Proxima B are aware of us, they might be waiting for a signal that we're ready, not just technologically, but socially and ethically. Any message we send would need to balance openness with security, carefully deciding what to share about our biology, culture, and location. This discovery comes at a time when exoplanet exploration is thriving. As of May 2025, over 5,500 exoplanets have been confirmed, with many more candidates awaiting study. Future missions, including the European Space Agency's upcoming atmospheric survey satellites, aim to deepen our understanding of which worlds might support life.